Number 18. Suppose a car is released from the top of the ramp. The string is not wound, so the car is powered only by gravity. The car travels down the ramp and rolls out onto a level surface. During its descent, the car's center of gravity drops 0.6 meters vertically. After rolling a total linear distance of 25 meters, the car comes to a stop. What is the net force of friction that is opposing the car's motion? Assume this force of friction is the same on the ramp and floor level. So the gist of this question is that in the beginning, this car has a certain amount of potential energy. And the potential energy it has is based on its mass and gravity and how high it is. When it gets to the floor, that potential energy is gone. So not only is that how much potential energy it had in the beginning, that's the only energy it had in the beginning. So in the beginning, it has this much energy. At the very end, it has none. So all of this energy is eaten up by something. The reason I know it has none at the very end is because once it gets to the level floor, it stops. And when it stops, all the energy is gone. No potential energy and no kinetic energy. The thing that eats up this energy that it had in the beginning is friction. If there were no friction, the car would roll forever. So all we really have to do is say that the potential energy it has in the beginning is equal to the work done by friction. And the work done by friction is the force of friction, the net force of friction, multiplied by the distance that the car moves. So here's what I wrote in my solutions. PE1, that's MGH, plus KE1, 0, because it starts from rest at the top of the ramp, equals PE2, that's 0. There's no potential energy at the end. This is when it stops. And this is at the start. The kinetic energy when it stops is 0 because it stopped. And all we're really left with over here is the work. I'll call it work against friction. So it's the force of friction times the distance that the car travels. So 0, 0, 0, everything goes away except for PE equals FD or MGH equals FD. This is the mass of the car. That's given somewhere in the question. Where is that? Total car mass, 0.2 kilograms, times 9.8 times 0.6 meters, that's how far it falls, equals the force of friction times 25 meters. Multiply all these together, I don't know what you get exactly. You'll get 25 times that, I think. And then divide both sides by 25 meters. And when you do, you're going to be left with the force of friction on this side, and this is all going to equal 0.047 newtons.